Today we're going to talk about the theorem of Thales. We're going to start out with a semicircle that has a center of O. The radius of the circle has a length of R. Now if I look at points A, B, and C, they lie on the circumference of this semicircle. Now if I connect points O to A, O to B, and O to C, they form three line segments. The measurement of AO is equal to the radius of the circle, which has a length of R. The length of OB is also equal to the length of the radius, which of R. And OC is equal to the length of the radius, which has a length of R. Therefore, AO has an equal measure as OB, which is also equal to OC. So these three line segments are equal in measure, and that's indicated by the two tick marks on each line segment. Now if I look at triangle OCA, I notice that it's an isosceles triangle because these two sides of the triangle are equal. They have equal measures, therefore the opposite angles of the sides are also equal. So this angle is 44.09 degrees, which means this angle right here is 44.09 degrees. So the blue triangle here is an isosceles triangle. If we take a look at the other triangle, OCB, I notice that it's also an isosceles triangle. Side OB is equal to side OC, which means the opposite angles of the two sides are also equal. Therefore, the red triangle, OCB, is also an isosceles triangle. If I'm looking at the bigger triangle, so if I'm looking at triangle ACB, the total of the interior angles have to add up to 180. So this angle right here, which I'm going to name alpha, and this angle right there, which is beta, so alpha plus beta plus angle ACB should all add up to 180 degrees. Notice that 44.09 plus 45.91 add up to 90 degrees. That means this angle right here, angle ACB, should equal to 90 degrees to have a total angle of 180 degrees. So what happens if I move point C along the circumference of the circle? So when I'm moving point C, I notice that my triangles are still isosceles. They remain the same. And angle alpha and beta are changing. So if I add up 71.18 and 18.82, they still add up to 90 degrees, which means angle ACB is still 90 degrees. So angle ACB is not changing. So what happens if I move C to the other side of the semicircle? So if I move it right here, angle alpha is 20.22 degrees and angle beta is 69.78 degrees, excuse me, which add up to 90 degrees. So that means angle ACB is still 90 degrees. So no matter where point C lies on the circumference of the circle, angle ACB will remain the same, which is a 90 degrees. So it's going to remain as a 90 degree angle. And that's it for today.